Thank you for your interest in our See and Learn Numbers programme and in joining me in this presentation. I'm going to provide an overview with hopefully enough information for you to see quite clearly what is in See and Learn Numbers and how you use it. But I'm going to start by sharing some information on the See and Learn programme and what the common design features are and developmental benefits across all the programmes. Then we'll focus in more closely on See and Learn Number, why it's needed, how we've designed it, what have we learnt from the research on children learning to count and calculate, and then how do you use it? Well, what is See and Learn? Well, we've been developing See and Learn practical programs now for several years in response to requests from parents and teachers. Over the years, we have drawn together research findings, we've run early intervention services ourselves, and we've shared the principles of our approaches in our presentations. But parents and teachers have come back to us and said, be really helpful if we went a step further and actually provided the materials and the teaching programs. So that's what we've done. And at the moment, the See and Learn programs cover language and early reading, speech, memory and number skills. So there are 4 separate programs, and within each of those, there are a number of steps taking children through learning in developmental order. All our See and Learn programs have some design features in common. So it's useful to look at these before turning to a specific program in more detail. Our approach to designing interventions is to start by looking at what we know about how other children learn. In other words, what do we know about how all children learn to talk or learn to count or improve their speech or their memory? Research tells us that children with Down syndrome build their skills in the same order. Once we have looked at what influences development for other children and what speeds it up and slows it down and interventions that might work if they're delayed, we then go to adapting what we've learned from that for the learning profile of children with Down syndrome. We draw on the research that has shown us that children with Down syndrome have a particular learning profile. They have strengths and weaknesses, and if we adapt our teaching to that, we may be more effective. All our programs have small steps and structure. We know at the outset that youngsters with Down syndrome are likely to have some cognitive delay or learning intellectual disability, and therefore breaking tasks down into small steps, making sure there's a structure building in developmental order, and then providing plenty of opportunity for repetition and practice to consolidate learning. We also design them all to build on the children's visual learning strengths. We know that their ability to learn from things that they can see is better than their ability to learn when they're just listening. So building on visual learning strengths by always using clear pictures, print, visual supports for learning. And supporting their verbal learning weaknesses by making sure we use simple and consistent language that is focusing on what we want them to learn. All the programs, because they involve individual structured teaching or working with children in small groups, they encourage children to listen and develop their listening skills, to develop their attention, to be able to attend for longer periods of time, and to concentrate on the tasks in hand. And this is important for developing their learning and preparing them later for preschool and school. Very importantly, all the programs are designed to be adapted to the individual child's needs. Children learn if they build on what they already know. It's very important that you can work through a program at a pace suitable for the individual child. and that the record sheets we provide and the guide and instructions we provide allow you to always be working at the child's individual pace. In addition, engaging in structured teaching activities and sitting down in one-to-one and small group activities, children learn a lot of behaviours which they use across all learning situations. They learn to listen, as we've said already, to follow directions, to respond to questions. They learn to learn by imitating and copying, by taking turns. They learn to initiate as we take turns. We can initiate, the child joins in. Then the child has a chance to initiate, we join in. They learn to learn through playing with partners. We also try to build into all our activities ways of teaching that support success. We are keen on errorless learning, prompting success in small steps, but then going on, of course, as children learn more, to encourage problem solving, for them to persist and complete a task for themselves and have the pleasure of feeling competent and what might be called mastering tasks and getting the self-reward of just completing them. All the programs provide graded teaching activities in small steps and in a printed kit or an app format. The materials in both are exactly the same, the illustrations are the same, so you could be using the printed kits in classroom and reinforcing that with app activities at home. They all have easy to follow instructions, guides that are the same in all the kit, in either print or app version of the kit, and very importantly, record sheets to chart progress. I've underlined already that keeping a record allows you to make sure you know what the child's learned and you're just teaching the next step. I'll come back to that later. Also, all the kits importantly include suggestions for consolidating and extending learning, or what the teachers listening might think of as generalizing, but extending learning into play activities and everyday activities at home or preschool. We know all children learn through all your interactions with them all day, every day, and those are really important. But we work on the principle that our children are slower learning and they will benefit from a short period every day of structured teaching that gives them that increased opportunity for repetition and practice to consolidate their learning. In other words, we don't think they will progress at the same rate without those periods of relatively intensive instruction each day. We're only talking about 15 or 20 minutes a day, but every day makes a difference. So the See and Learn Speech program is designed to improve speech skills and speech clarity. That's the clarity with which children can actually say words and sentences. It's improving their accuracy of production. The See and Learn Language and Reading program develops language by teaching vocabulary from very first words through to joining words together in sentences and learning the grammar, and then to improving children's ability to talk and join in conversations. It also includes activities to develop early reading skills for preschoolers. See and Learn Number is designed to teach the basics of counting and the first steps that children have to understand the number system. See and Learn Memory is designed to improve children's memory. Now, children are doing all these things alongside each other in their early years. They're both learning to talk, improving their speech clarity, learning to count, improving their memory. So we will be encouraging you to use activities from each of these programs alongside each other for short periods every day. Now let's focus in specifically on See and Learn numbers. Now, we've designed this to help parents and educators teach children basic number skills and concepts. We're very focused on trying to ensure that children really do understand the fundamental number concepts and processes before moving on, because we think sometimes this is not the case. And we know that many children with Down syndrome struggle with counting, calculating, and possibly this is because we haven't taught the very initial concepts as well as we might. We know, and many teachers will tell you, that in fact learning to count and calculate is a challenge for many children, not just those with identified learning difficulties. And in fact, we've drawn on the information around help for children with more delayed development of maths to design our program. To master early math skills, children must actually learn a number of basic procedures and concepts. What are they? I'm going to step through these on the next slides to highlight that there's really quite a lot to learn. Let's think about this from right at the beginning. In order to learn to count, children have to learn to say the number words. And this is a new experience. This is a set of words that we're asking them to learn and keep in the correct order. That's going to be a challenge for children with Down syndrome who may have difficulty saying words and also have verbal short-term memory delay. So learning a list, keeping these words in the correct order, is a challenge. We also need to know that numbers are represented by written numerals. So children have to learn to link the spoken number word with the correct written numeral. And then the first step into really understanding what these words and numerals represent is to understand that there is a specific quantity linked to each number. So they have to understand which quantities link to which numbers. That 3 is always 3 items, that 7 is always 7 items. Then we have to be able to count. And now this is again requiring us to keep those number words in the right order, to say the words in the right order and then to use them to count. And typically as young children start to learn to count, they're going to put one finger on each item. And of course you need to put one finger on each item, count each item in front of you only once, not miss any. That requires what's called one-to-one correspondence. It requires you to be able to structure your counting. So you do what I've just said. You count each object once, only once, and you don't miss any. Now, children get to the stage where they can count. Most of this is learned in their preschool years at home. Parents teach them the number words. They practice counting games. Many children at 4 can count objects correctly up to 10 and beyond. But at the first stage of being able to count accurately, they still do not understand what they're doing. They still don't understand that we count things to find out how many we've got. And the test for that is asking a child how many when they've counted. And you will find there's a stage at which you put 6 blocks in front of the child. They count 1, 2, 3, 4, 5, 6 correctly. You then say to them, how many have we got? They start counting again from 1. They've not yet learned that the last count word, 6, is the cardinal word and tells them how many. And that is the first step towards cardinality. Now, while the first step towards cardinality is learning that the last word tells you how many, it's the cardinal word. The test that is really used to demonstrate a child understands the cardinal principle, that we count to find out how many, and that we do understand these words represent fixed quantities. The first step to demonstrating they really understanding that is when, if you give them 6 blocks and they count 6, and you then say to them, can you give me 4, that the child can do that. They can give you 4, they can give you a smaller quantity from a bigger set on the table. Now it may surprise you to know that for young preschool children, for all children, mastering this cardinal principle takes at least a year. And as they start off, they can give you one correctly, and then the researchers call them one knowers. And then they can give you two correctly from a bigger set, and they become two knowers. A little bit later, they can give you three correct. They can do 1, 2, and 3, but not 4. So at that stage, they're 3 knowers. When they can do 4 correct, they're 4 knowers. When they can do 5 correct, they're 5 knowers. And by that stage, it would appear they begin to understand this principle that you count to find out how many, and each count word represents a specific quantity. Now, some researchers in the UK still feel we haven't quite understood this cardinal principle till we understand equivalence. And they point out that many children in their preschool years understand quite a lot about quantity before we start to try and teach them about the absolute number system. So, for example, they can quite cheerfully share out cookies or sweets between several children. One for you, one for you, one for you. They can share them out equally. They can tell us each child's got the same quite confidently. But then if you ask that child how many the first child in the group's got, the child counts the sweets, and that child's got 4. You then say to them, how many's the next child got? And they start to count again. Now, when they've really linked what they understand about same with the absolute number system, they won't need to count the second child's sweets or the third child's sweets, because when they've counted the first child, they know everybody must have the same number. Okay, so that's understanding equivalence. Once the child can share things out, tell you they're the same, only needs to count one set, and then knows the others must all have the same number, they've got equivalence. All those things need to be learned before we really move on to any sort of calculating, adding, subtracting. The next thing also that needs to be learned is that each next number is one more equal unit. That these words do have very specific meanings, and that as we go up the counting system, each next number represents one more equal unit. Okay. They also, of course, have to understand the relative sizes of numbers. They have to get the fact that each number represents a specific quantity, and that doesn't change. 9 is always 9 items, and so on. But then they also have to realize that 9 is bigger than 5, and 4 is twice as big as 2. They have to begin to understand the relative sizes and the relationships between numbers. Now, learning about early number skills also involves learning a lot about words, learning about quantity words, what they mean, and how we apply them to numbers. So as we're moving on, we need to understand words used for the comparisons of numbers. And I've used some of those already, that a number is bigger or smaller than another number, that it's more or less, or same or different. Okay, so we need to learn a lot of words that carry with them quite difficult concepts, because something can be more than another quantity but less than a third quantity. So for example, 6 is more than 4, but 6 is less than 9. And these are relative comparisons, okay? And these comparative words are really quite difficult for children. So we need to pay attention to the language that we're using. When a child gets into preschool, kindergarten classrooms, the word more probably means more dinner, more of something, not this is more than that. So we need to pay attention. And for our children with Down syndrome, of course, they're learning vocabulary more slowly. We may start to use words to talk about numbers and number concepts that they're not entirely understanding, so we need to pay attention to that. And then as all children progress into beginning to count, they go through 2 steps. To start with, they apply count all strategy. So if you ask them to add 5 plus 2, the example on the slide, they will count out 5 blocks correctly, count out 2, and then have to start counting again from 1. At this stage, using the number system, they always have to start from 1 to recite it in order. And it reflects also, of course, they're still not quite representing whole numbers in their heads as representing any point where you can start. in the number system. And then as they get more experienced, you see them moving to a count-on strategy. So having counted out 5 and counted out 2 blocks, they can then start adding by saying 5, 6, 7. And we can put strategies in place to help with all this learning. And as they begin to learn about manipulating numbers and adding and subtracting, they need to know that adding is the inverse of subtraction. If you take 2 items away and then put them back, you'll have the same number of items you started with. And I hope having just outlined the most important things that we know children have to understand, you will see why learning to count and learning to understand the number system is probably a bit more complicated than we often consider. Then if we take a look at research that has investigated what sorts of things help children to progress faster or what sorts of things hold them back, we'll use some of the key messages on this slide. Research studies have shown that parents talk about numbers influences children's understanding. And obviously playing lots of number games, lots of repetition to learn the words, lots of counting activities matters for all children. But also research has shown that counting sets of objects with children, including counting sets larger than the child can count on their own at this point, will help them. And that kind of reflects the fact that parents scaffold children's learning in all areas of development. And they do scaffold it by helping a child complete something that is a little bit more difficult than the child can do on their own. So that's an example of scaffolding. We also know from research for all children that children who have language delay have a more limited phonological awareness, the ability to hear sounds in words, have working memory delay, have attention issues, motor delay. These all affect the speed at which they learn to count and calculate. People looking at strategies that work when teaching have shown that new concepts, difficult new concepts like number and colour words, are learned faster when they're the last word spoken. So, for example, if we say, look, balls, there are 2, rather than there are 2 balls, or we say the ball is red rather than it is a red ball, studies have shown children learn those new concepts for 2 and for red more quickly when the new concept is the last word. When we look specifically at work on learning to count, the guidance from the experts looking at this early development is to make sure to start with children are using counters that are all the same size, shape and colour. So the only way in which they vary is in quantity. In other words, there's no confusing features. The counters are all the same size, same shape and same colour. It's also suggested they should be in a line, that counting from left to right in a line helps children. And there are other studies that show simple games, counting games with numbers up to 10 in a line may also help, do help, and have been shown to help as classroom activities as well as with individual children. So I've given you a little bit of an idea too, again, about our thinking. Linking back to the initial introductory slides, we're stepping through this. What is it children have to learn? How do they do it? What do we know about children who are having difficulties? What do we know might hold them back in terms of the child characteristics? What do we know about teaching strategies that may help them to learn? 2 other things that research has suggested: systematic daily teaching in small steps. Some of the work, particularly in the United States, about children with more delay in mastering the number system and getting to count and calculate, they advocate systematic daily teaching based on their review of studies in small steps in developmental order with that repetition and practice. There's also evidence that computer games may help for all children, including children with Down syndrome. There's not a lot of work on computer games, but what there is says they are helpful. So what do we know then about number learning specifically for children with Down syndrome? to go from what I've explained already to thinking more precisely about the needs of our children with Down syndrome and whether we want to make further adaptations. Now, there are a number of studies surveying how far children with Down syndrome get with counting, calculating, money, time, and so on, because those are all part of the math curriculum. In general, many children with Down syndrome find counting and calculating difficult. Many children are not able actually to count, to add, subtract, multiply, and divide confidently with numbers up to 20 or beyond. Some children do very well. Some children are keeping up with their age groups and class groups. There's this very wide range of ability, whatever we look at. But it is clear that cracking, understanding the number system and being able to use it is difficult for many children. We know from the studies of inclusive education from a number of different countries that children in regular general education classes have often got further with their number skills. We also know from comparative studies that very often children's progress on the math curriculum is lagging behind their progress with literacy by as much as 2 years. Their reading is ahead of, for the same children, their reading ability is ahead of their number ability. There is some evidence to suggest at the early stages that children with Down syndrome can do well. Research from our own team, the work of Joe Nye some years back, showed that at those early stages of counting and understanding cardinality, the youngsters with Down syndrome were keeping up almost completely with children matched for non-verbal ability. Now that means those children they were matched with were younger, but at the stage where they showed the same level of non-verbal understanding. The children with Down syndrome showed they understood cardinality. They could answer that how many question and they could give a smaller number from a bigger set. They'd mastered cardinality as well as the children they were being compared with, and Joe followed them over a 2-year period as they were learning to count. But the difference was the children with Down syndrome had mastered a shorter counting word list. So, for example, if on average our typically developing children could count to 14 accurately, they could recite the count word list to 14 correctly. The youngsters with Down syndrome were perhaps reciting it correctly to 10. Now that's what we might expect because learning that number list is a memory feat, and we have children with delays in verbal short-term memory development. We'd expect learning long lists to be a challenge and saying the words to be a challenge. So the children could count only slightly smaller sets accurately, but their understanding about what these numbers represented was as good as the children we were comparing them with. Now, we have tried to get more money to carry that research on because what the data I mentioned at the start of this slide says, later the children are having more difficulty, but it seems to us that early on we should be able to build on what we demonstrated in that study. Now, the math program in schools doesn't just cover learning to count and to calculate. It also covers a lot of other early concepts that overlap, that may be setting the scene for geometry, statistics, and so on, but also are relevant. Some of this language is relevant to just the number and counting and calculating and money systems. So we have to learn size, we have to learn shape, we have to learn colour. And at the start, we teach children something's big or little, tall or short. Okay. But, so those are category words. These are shapes, these are sizes, these are colours. Okay. And we can sort by shape, size and colour. But more complex classification becomes more difficult if we've got shapes that also vary in colour. Now you could sort them by colour or you could sort them by shape. And that is a bigger challenge to children. And if they vary in size, like the example on the screen, some are big and some are small, some are red, some are blue, then again we can sort them either way. And we have to be able to ignore one feature or attribute of the objects and sort on the other. And those things are all challenges. So now I'm going to turn to specifically describing a See and Learn number. The whole of the See and Learn numbers program is designed to teach children to count, link numbers to quantity, understand concepts as I've just outlined, that to go through those concepts I've outlined about the number system until they can use them with numbers up to 10. They understand cardinality, they understand equivalence, they understand comparisons between numbers, and they can add and subtract with numbers up to 10 before we move on. And also that we're going to cover early mathematical concepts around space-time measurement, including the colour, size, shape, ordering things in size from smallest to biggest, or biggest to smallest, or tallest to shortest, as well as sorting, and then learning to create repeated patterns with particular repetitions in them. Those are all things that are considered early for children to master in terms of moving forward on the maths curriculum. Now, to just link and remind people of some of the design features that I talked about in general and how those are embedded in our design of the number steps, we have small developmental steps starting with learning number words and proceeding through those skills. We're doing it in a clearly defined progression. We have records for you to chart that progression and know when to move on. We will build in practice and repetition. We don't move on until each step is mastered. We've tried to use very clear and consistent visual representations for the numerals, the written numerals, counters in the kits, simple black counters on the distraction-free app screens, and a consistent horizontal 1 to 5 counter arrangement, drawing on the guidance from the experts. We've also used simplified language with minimal clear spoken prompts, and these are set out in the guides. You're given exactly instructions on how to step through the materials and the language to use with your child. We are planning at the moment these 3 steps: See and Learn First Counting, which is published, See and Learn First Concepts, and See and Learn First Sums, which are in development. Now, all this, when would you start on the number program? Like all the other programs, these are to be done in order. Okay. You could work at first counting and first concepts alongside each other. Children are learning both during their preschool and early school years, but you would need to do first counting before you move into first sums. Okay. So it's building up like all our programs from the very earliest steps, the foundations for the skill, and how do we build on that. So it's suitable for children who understand and can say or sign at least 100 words. And there's huge variability in the rates of progress for children with Down syndrome, but we expect this to be around 3 to 4 years of age, where we might begin learning about numbers. Obviously, the materials are suitable for older children who are still learning the concepts I've stepped through. And indeed, the materials that we provide will allow you to test your child's understanding. So if you've got an older child who you think is already counting, you can test whether they've got cardinality. Can they give you a smaller sum from a bigger sum? By using our materials, of course, in the kit or the app. You could test whether they understand equivalence. Okay. So we want to sharpen up people's thinking about what children understand, and I will return to that later. Now I'm going to focus in on See and Learn First Counting, which is the one that is published and available. And this goes through that list on the screen. There are 6 activities in First Counting. And I'm going to say a little bit more about each one on subsequent slides. But they're teaching children to say the number words, recognise the numerals, link numbers to quantity, and understand the concepts of cardinality and equivalence for numbers 1 to 10. And indeed, in fact, we advise you to step through the levels of understanding with only numbers 1 to 5 first, before we start to work with larger numbers. And we do introduce some key maths language as we go. Also, in the illustration, you can see in the kits there are numeral cards. There are also cards with the quantity indicated. And when we get to concepts of cardinality and equivalence, you can choose whether you have a teddy or a monkey. And the teddy receives cookies, the monkey receives bananas. Okay. Now, here's examples of pages from the guide for first counting. All the guides have same sort of structure, layout and design across our See and Learn programs. Again, consistency, which hopefully makes them easy to work with. They all include at the start background into how we've designed, the sorts of information I've just been through with you about what we know about research and how that's led us into working in the way that we're working, and guidance on setting the scene, background things you might think about to make teaching effective. And then for each activity, absolutely explicit guidance, as you can see in the third page here, of how you step through an activity, step by step, small steps, clearly set out and precisely described. So you've got precise instructions, and you could also see, of course, that the instructions for using the card materials and for using the app are set out side by side in the guide. And I think I might have said earlier, the materials, all the materials in See and Learn, we are now publishing in a printed kit form or in an app form. And of course they work together. So if school wants to work with kit materials, the child can practice at home, and the app version may be easier and more friendly to use at home for parents. Here you see examples of records. Specifically the first counting record booklet, and again this is common, these booklets and format are common across kits, but here in particular you've got two examples which we'll come back to as we look at each step. You've got an example of the number words record, and you will see what I've just said. We're encouraging you to go through all these things, doing 1 to 5 first and doing it as 1, 2. When the child can say 1, 2, then you practice 1, 2, 3. When they can say 1, 2, 3, we add 4. This is list learning, and we know that this kind of learning, we want to start always at the beginning of the list. We want to add one on, and when we can do 2 items, we do a third one, and so on. So list learning, and you can see we've broken this up to remind you we're going to do 1 to 5. And if you look at the cardinality record, you can be moving on to understand cardinality with numbers up to 5 before we go back and are learning numbers to 10. So quite specifically in this first counting kit or app, we have what are actually 6 activities. I'll explain that. Activity 1 is learning the number words. Activity 2 is being quite sure we've learnt the numerals and we're associating the right numeral with the right spoken word. And that is broken down into matching, selecting and naming activities. So they're 2A, 2B, 2C. And then 3 is linking quantity, and 4 is learning to count, and then 5A, give a number and learning equivalents are both linked as cardinality, so they're 5A and 5B. So actually there's 5 activities, but some of those have more than one part to them. And you can see on the screen, clear printed cards, identical black counters. You can see on the app screen, likewise. In fact, in the app, you can actually change the color of the counters and the shapes, but they will still be identical, whatever you choose. So the first activity is simply to teach your child to say the number words. And for a long time in our early intervention service, we've used the written numerals as a visual prompt. You remember I said we know our children with Down syndrome find learning just from listening difficult, and so we're always looking to give them a visual prompt to help them to link the spoken word to. So we would have their finger on the numeral 1 when saying 1, on the numeral 2 when saying 2. So we've used the numerals as that visual prompt for remembering spoken words. And so here this child may be going through them all up to 10, but they will be touching each one as they go. Okay, so in fact, in the activity to teach these numerals, the digits come up one at a time. So there'll only be one on the screen, and then 2, and then 3. And you set it, of course, to learn 1, 2, 1, 2, 3. Okay, in the way I've already described. Activity 2 is learning the numerals. Now, your child is going to begin to learn these numerals while learning to say them, because we've got their finger on them as they're saying the words. But we've put in activity 2 to make absolutely sure they have learned the numerals. In the first activity, we're concentrating on getting them to say the words. In this activity, we're making sure they are actually recognizing the written numerals. And we're doing this with matching, selecting, and naming games. And if you've not heard that strategy before, matching simply requires the child to put the numeral you hand them with the one that's the same. So in that example illustrated on the screen, you're handing the child 4 and asking them to put 4 with 4. Okay. At this stage, they're just matching. So they've just got to see they're the same and match it with the one that's the same. When we think they know those numbers, when we think they can recognize the numerals 1, 2, 3, 4, then the selecting activity will be to point to the correct numeral. Show me 4. Okay, so we may introduce the activity with let's point to numbers, and then the instruction is show me 4, and the child's got to point to 4 or show me 2. And then the last step is to be able to say let's say numbers. You show them 4 and the child says 4. Okay, now we teach lots of things in these matching, selecting, naming steps, and you will know your child actually understands, can pick the right number up when you say show me 2, show me 5. They may be able to do that consistently quite a while before they can say the words clearly. Okay, so you're testing their understanding, their comprehension at the selecting stage, and then their ability to say. And of course they may learn, then their ability to say. And I've stressed already, we work in very small steps, 1, 2, then 1, 2, 3, and we do it always in order to start with. The children are always being asked to do that matching by being handed 1, put on 1, handed 2 to put on 2, handed 3 to put on 3, because we really need to overlearn keeping the numbers in the right order for counting. Now here we have the record sheets, one of which you've seen already. You can see straight away again that we are stressing do 1, 2, then 1, 2, 3, then 1, 2, 3, 4, because this is list learning. If your child can say the words 1, 2, 3, then we can move on to consolidate that they recognize the numerals 1, 2, 3. So you're going to move across these activities based on your child's rate of progress. So the child who can say 1, 2, 3 can move on to match numerals 1, 2, 3, select numerals 1, 2, 3, and then we can move on to linking quantities 1, 2, and 3. While still we're learning number 4 and number 5 back in the number words record, and we're learning to recognize the numerals 4 and 5. So we can be moving across, teaching children to understand quantity and move forward with just the numbers they know. And indeed, we would argue it's very important that they understand the difference between 1 and 2 items before. So learning to link numbers and numerals to quantity, we need to go slowly and make sure they understand the difference between 1 item and 2 items and 3 items. And until they can do 1 and 2, we won't add 3. And now activity 3 is linking quantity to numerals. The children have to understand what these number words mean, and that they represent quantities and what those quantities are. And as I've just stressed, starting with 1 and 2. And for some children it may take quite a long time before they can consistently, if given 3 identical objects, they consistently can give you 1 or give you 2. Okay, that they know. Now we're going to start trying to teach that in, again, a very structured way. So you're going to put out one counter, 1 is 1. Then you're going to put out 2 counters. Child can put the counters by the card. On the app, the counters move, and you can again tap or move them with your finger. But also on the app, the child is forced to complete the quantities in the correct order before moving on. So you've got to do 1, then you've got to put 2 counters on 2. You've got to put 3 counters on 3 before you can put anything on 4. So it's forcing the child to pay attention to the exact quantity that goes with each spoken word and numeral. Okay. And again, it's forcing this in 1, 2, 3, 4 order over and over to start with. Once the children have really got it, obviously you can randomize the games. So activity 4, we're now moving on to count. To do the quantity exercise in activity 3, the child does not actually have to be able to count. They are matching counters to markers to learn those quantities. In activity 4, we now want them to count. And now we're asking them to count the counters and choose the right digit card for the number they've counted. We would urge you to start with 1 and 2 only, and until they can consistently give you 1 item or give you 2 items from an identical set of 3, then we wouldn't move on to start doing 3 or 4. Okay, so they need to be able to count 1 item, count 2 items confidently, and understand the difference between the quantity 1, quantity 2. Now, when you're counting, of course, you need to get this one-to-one correspondence. Normally, children count by putting their finger on the items, and you may need to help your child do that. So you can manage the motor part of this. You can help them keep one finger on one item while you concentrate on saying the count words together and encouraging your child to repeat those number words. We again always start in order, counting 1, then counting 2, then counting 3. Okay, so, and again on the app, that's how it will come up. 1 counter will appear, you count 1, you tap the numeral 1, then 2 counters will appear. So lots and lots of repetition prompting success. Remember we said earlier that small steps and prompting success matter. So we're really keen to prompt success and really give the children lots of repetition of things that are correct. Okay. Now on the app, when children start to learn to count, they are going to count probably from left to right, 1, 2, 3. But in fact, of course, you can count a set of objects in any order, provided you only count each item once, you don't miss anything. And on the app, when you turn the voice on, it allows that to happen. So if the child touches the counters in any order, it'll still say 1, 2, 3. So you can count them backward. You could touch them in any order, and you'll still end up with the right quantity, the right final count number. Now, activity 5 is stepping into cardinality. And this is a game to help your child to learn to give a smaller number from a bigger set. So the example on the screen, the child is being asked to give Teddy 3 cookies. There was four to start with. The child's put 3 up to the Teddy, moved 3 cards onto the Teddy, and the app will not allow you to put the 4th one up. So on the app again, we are forcing errorless learning. We're forcing the child to get this correct while they're learning. Okay, you could change these settings, but it starts off as errorless learning. And you can also choose whether you're going to teach your child to give 1, and when they've got that 1 knower status, you're going to teach them to give 2 until they can do 2 1 and 2 items successfully, then you're going to do 3. You can decide how many counters you're going to ask them to do 2 out of, to give 2 to the bear out of sets of 3, sets of 4, sets of 5, sets of 6 as you go on. Okay, so both with the cards and with the app, you're going to step this up little by little, okay, based on your child's progress and whether they're a 1 knower or a 3 knower, okay, and whether they can count to 5 or count to 8. You can turn that numeral prompt off. Here we're saying, can you give the bear 3 cookies? And we're leaving the 3 there because we have a verbal short-term memory issue. When the child starts to count out loud and say 1, 2, 3, they may have forgotten the instruction. If you've got the card kit, we'd suggest you put the numeral card alongside the teddy. So again, visual prompts to prompt success. Now, the last activity in first counting is an equivalence activity. And this is to check that they're going to link their understanding of same, that something's the same, and they know they've shared equally, and each child or each bear has the same number of cookies or bananas or sweets. We're getting to the stage where they know, if they know it's the same, then it must be the same number of items, and that there's no need to count the second set. So what you're going to do is put out your 2 cards, put out a number of cookies or bananas, an even number so they can be shared equally. Ask the child to share them, so it's 1 for you, 1 for you, until the 2 animals have got the same number of items. Then you're going to say to the child, are they the same? The child will say, yes, they've got the same. Then you're going to say, how many has the first bear got? And the child counts 5 cookies. And then you're going to say, okay, so how many is the second bear? How many has this bear got? And of course, once they've got it, they won't need to count. While they're learning, they will count that second set. Okay. So we're going to proceed with that until they can tell you the number in the second set without having to count. You can again vary this so that you're working up from sharing 2 cookies, sharing 4, sharing 6, up to sharing 10 once the child can count to 5, and then increasing, of course, to sharing up to 10 items for each animal once the child can count to 10. In the kit version, you have enough counters to do all these activities. You have 60 counters in the kit, which allows you to do your quantity task up to 10, putting the right number of counters with the numeral cards up to 10, and it allows you, of course, to have 20. When you get to this, you've got 20 picture cards of cookies and bananas, so you can do sharing up to sharing out 20 items. Now, for each of the activities we've gone through, there's a record sheet. Okay. So for each specific activity, whether it's learning counting, learning cardinality, there is a specific record sheet for that activity. But we thought it might be helpful to give you an overview progress record, because I said earlier, once your child can say 1, 2, 3, and knows the numerals 1, 2, 3, then we may be linking quantities 1, 2, 3. So we'll be moving across this. Your child may be doing counting up to 3, but still learning to say 4 and 5 and recognize numerals 4 and 5. So this just allows you to have a summary of where your child is on each of the steps. Which number words can they say? Which numerals have they learned to match and select and name? Where are we with quantity? And that's going to be a step that really becomes conceptually more difficult. Okay, having learnt to say number words and learnt to match numerals, beginning to understand what they actually mean, that they represent quantity, is the step that we start getting conceptually more difficult, that they have to understand about quantity and what quantity the number words and numerals represent. And then of course we're going to do the counting, and again I've told you you can rote count but still not really understand what you're doing, although if we've done the quantity activities we should be setting children up better to understand what they're doing when they count, that they're counting to find out how many, and then you're moving in of course to check that they're understanding that with the cardinality exercises and the equivalence exercises. Now, the next step of CLearn number that's under construction is first concepts. And this is designed to teach children about shapes, colours, size, ordering, comparing, sorting, and sequences. Okay. It's designed in the same way. There'll be matching, selecting, naming activities, and on the screen you've got an example of learning colours where we've got as far as 4 colours, though we would start with 1, then 2. Are we sure the child can discriminate 2 before we add a third? Okay, but here you would be matching. The child will be being asked to put yellow with yellow. Okay, and then green will come up, put green with green. And then we will be show me blue, and the child points to select the right colour, and then naming. So again, matching, naming, selecting. You can do that with shapes, colours, sizes. You can do it as you start to teach them to order in size and so on. And of course here we're teaching some very important language concepts. And here's a list of the activities, which highlights what I've just said, that teaching both size, colour, shapes and positions we can do with matching, selecting and naming activities. And then we're going to get into these more difficult sorting by colour and shape, where to start with the things will only vary on one attribute, there'll only be different colour or different shape. Then we can make that more complicated by varying them on more than one attribute. Comparing sizes, bigger, smaller. Learning to order by size, learning to sequence based on repeating patterns. Okay. Now, one of the things I maybe should have said much earlier in the presentation is I think you will have already realized that the materials we're producing go in very small steps. And that makes them different from a lot of the other early number activities that are out there. Many teaching programs, particularly apps, go much too fast for our children. They don't have enough small steps to really make sure they understand at each point before you move on. And they don't allow the repetition and consolidation. Now the third step in CLearn number is first sums. Children will be ready to move into first sums when they've completed first counting. They need to have all the basics in place and be able to complete the tasks in first counting before they move to first sums. And then first sums is going to go through teaching children to add, subtract, multiply and divide with numbers and quantities up to 10. It will also of course be reinforcing those concepts about the relative sizes of these numbers, how they compare with each other, which is bigger, which is smaller, and why 2 plus 2 makes 4. It will also be reinforcing, of course, ordinality, that each next number is one more equal unit, and that children understand if you've counted a set, you then take 2 items away, you then put those 2 items back, you will have the same number that you started with, the same number of items in that set. And of course, it will be teaching the language needed, which gets more complicated at this stage of number learning. These are the activities then which will be covered in first sums, and it covers the concepts I've outlined: children adding 1, taking away 1, playing that race game which we know helps them to really understand. Numbers represent specific quantities, games for counting forwards, counting back from any number, learning relative number size, addition, subtraction, number bonds, the different pairs of numbers that make 10 or 6, and learning simple multiplication and division, and doing all that with numbers up to 1 to 10 before going on to learn about place value and numbers bigger than 10. and how they're represented. Now, some of you may also wonder how this all fits in with the Numicon system. Many of you will know we encourage people to use Numicon. We think it's very well designed. It is a wonderful set of materials that gives you shapes that give you accurate visual spatial representation for whole numbers, show you very clearly that each next number is one more unit. But the people who designed Numicon assume that children have basic counting skills in place. In other words, the early Numicon activities are not focusing on teaching children to count, to learn those count words, to understand quantity, to demonstrate cardinality. All these basic skills are assumed to be in place, and we need to check that they are. When using Numicon to teach math, we really do need to check that children have those basic understandings that are covered in first counting. By the time we get to first sums, this is where links with Numicon will become clearer. But if we're not careful and we introduce Numicon when children do not understand about quantity and counting to the stage they can complete first counting, then there's a very real risk we teach the child this plate is called 1, this plate is called 2, this plate is called 3, this plate is called 8, and they actually have no idea what the concept 3 or the concept 8 or the quantity 3 or the quantity 8 actually is. And they don't have cardinality. They cannot demonstrate they can give you a smaller set from a bigger set. There's a danger you can teach the children to label those plates and even do some of the activities and say this is, well, to do some of the activities and appear to understand, but they don't really understand what those plates represent. So, thank you for listening to this presentation. And the next slide illustrates the contents of the first counting kit. In the kit, those are the items that come with the printed kit materials. And as I said already, you can do the same activities with the app, but you may be interested to know what materials we've provided in the kits for teaching these early first concepts. And here's the information you need to go further. If you go to the See and Learn website, you'll find there's a lot of information on the See and Learn number website, some of which I've stepped you through. There's references to the research and so on. If you want more advice and information once you start to use the materials, then join the See and Learn Facebook group. That's a very helpful place to go because on Facebook, if you post questions, we can answer them, and they will be shared, of course, with everybody else who's using See and Learn and may be asking some of the same questions. And then there's the links to go to the stores if you wish to purchase the kit.